Okay, so welcome back. This is part 6 in our series where we show you how to develop an application like you see here on the left, which is a computer hardware monitor. In this case, it's a C# Visual Studio application. And we talked in previous videos about a free and open source hardware monitor like you see here. And this is called Libre Hardware Monitor. And again, free and open source on GitHub. And it is what's called a fork of the open hardware monitor that was started back in 2010, I believe. And that kind of died out, and then Libre Hardware Monitor was forked, and a bunch of other versions, but seems to be the more popular version. And you can see here it allows you to measure a lot of different properties of the different components. Like here's your motherboard, the CPU, the memory, GPU, storage media, and so on. And it allows you to monitor all of those. And we showed you in previous videos how to get this Libre Hardware Monitor, how to download it, and how to generate this application. And we also showed you that if you want to use the basic functionality but not generate this application, you want to make your own application like you see here on the left and just access the library that runs this application. We showed you how to do that, and it's basically a NuGet package version of this Libre Hardware Monitor. We showed you how to add that to a brand new C# application and access the data on your components. And in this case, we have our GPU and a real-time temperature that we're displaying, and we're also charting the last 10 minutes of the measured temperature. And you can see right now it's 49 degrees C, and if you look at the Libre Hardware Monitor application, the GPU core temperature is 49 C, so it's matching exactly. So we showed you how to deal with this free open source project, but we also talked about some of the downsides of free and open source software. People love it because it's free, but we also talked about how there are many downsides such as documentation. Usually when you have a free and open source application, there's very little documentation, if any, and this project is no different. There's virtually no documentation, and that's because basically software developers, coders, don't like to write documentation. And when you're doing free stuff like this Libre Hardware Monitor, nothing is pushing you to make documentation, so you do whatever's fun. So there's no documentation for this, and it's about 35,000 lines of code. Very complicated. We talked about how with all of the different components, the motherboard, CPU, memory, GPUs, and all of that, there's a lot of different manufacturers, a lot of different components, a lot of different sensors and values. So this can get really, really complicated, and without documentation, it can be extremely difficult to figure out, and that's the case with this. And in the last video, we said, let's step back and see how we can develop this application here on the left, which doesn't use this Libre Hardware Monitor library or anything else associated with it. We're just going to develop an application from scratch and grab one value, in this case a temperature, from one component, this GPU, and chart it on this chart. And that will give us some basic knowledge and comfort with being able to figure out the process for, identifying what's out there, what are the registers, what is the data acquisition hardware, how do we access it, what's the communication path we talked about in the last video. And we also said all of these different components have different methods for grabbing data, but this will just be one to get us a little bit more comfortable with how we can do it, so then we can move on to another one. So what we're going to do in this video is we're going to show you how to develop this application here, which is measuring, like we say, GPU temperature for one GPU. However, we are going to do this by trying to access directly the GPU, not use a library like Libre Hardware Monitor, but we chose a GPU under the assumption that, in this case, an Nvidia GPU, they generally have some really good APIs that allow you to directly access and control the hardware. And this might be a fairly simple entry into how we can do that communication and get us comfortable so we can move on to the other components like CPU and others in a future video. And to give you an example of this monitoring, I've just started up in the background a 3D render that basically utilizes my GPU 100%. You can see over here in Task Manager, the GPU CUDA core is running 100% utilization. You can see the temperature is going up past 65, and it's matching exactly what it shows in this Libre Hardware Monitor, and also in any other monitor it's going to match exactly 65C. So here we are a few minutes later, and the rendering process has stopped. You can see in Task Manager, in the GPU, the CUDA engine has gone from almost 100% utilization down to 0. And you can see in our plot, the scrolling chart says it went up to just under 80 degrees, and now it's recovering, dropping down to 68. And that matches what's in the Libre Hardware Monitor. And again, we're not utilizing this Libre Hardware Monitor in this application. We're going to show you how to do it by directly talking to the Nvidia hardware. Now, one of the other benefits of doing it this way is not only we learn how to do it, but we also get rid of all the complications of somebody else's software. You can see, as with most of these hardware monitoring apps, they give you access to just about every piece of hardware and every sensor, and most people really don't care about 90% of that. So it allows us to focus on the things we care about and also do things like special charts that we want and to customize it rather than relying on free and open source software support, which is generally non-existent because people are busy doing what they think is fun and they don't want to work on a feature that you care about. They only work on something they want to work on because they're doing it for free. So this gives you an opportunity to do it yourself and fix things and have an application that runs the way you want. So now, what magic are we going to use in order to sense the GPU we have and grab the real-time temperature so that we can plot it? Well, thankfully, as we had hoped, Nvidia has provided an API, an application programmer interface, that allows us to do just that. Called the Nvidia API, or NVAPI, and the documentation at developer.nvidia.com for NVAPI says it's core software development kit that allows direct access to Nvidia GPUs and drivers on all Windows platforms. Provides support for operations such as querying the installed driver version, enumerating GPUs and displays, monitoring GPU memory consumption, clocks, and temperature, and others. So that sounds like exactly what we're going to need in order to monitor our GPU. Now, there is documentation here. You go to docs.nvidia.com and you will see a lot of stuff. GPU APIs, control interface for controlling, thermal controls, performance state, clock control, cooler interface, which allows you to get temperatures from the GPU, which is something we're going to use. And then there's video APIs, DirectX, and so on. So we're going to use this NVAPI. There's one other called NVML, which is management library. Doesn't have as much functionality. So for now, we're going to stick with NVAPI. And in fact, the Libre Hardware Monitor software uses this NVAPI as well as the NVML management library. So it's kind of the key component if you're going to access your GPU. So we're going to show you how to use this NVAPI. Now you can look through this documentation on the NVAPI with all the defined structs, enums. There's tons and tons of stuff here. However, thankfully I found a wrapper that allows you to use in your C# applications. It allows you to access these a lot easier with .NET Framework. And that is at GitHub, NVAPI wrapper. Now again, I try not to use GitHub and free and open source. In this case, it will at least give us an example of how you can access the fairly complicated NVAPI based on a .NET Framework project. So we're going to use that in our application, and it will make it very, very simple to grab the GPU and the temperature in real time and plot it. And then once we have that, we can kind of reverse engineer this, and it's really a whole lot easier to see what it's doing under the hood if we want to get rid of this and just do it all ourselves. Now this NVAPI wrapper The last action was about 4 years ago. So again, this has been sitting around for a while. Doesn't mean it's bad, but you have to be careful. But at least this will get us going and give us a basic core of how to use Nvidia API to get to the GPU. So let's take a look at the application I developed using this Nvidia API and see how simple it is to grab data from the GPU. So now here is our simple C# Visual Studio Windows Forms.NET Framework application. And you can see there's not a lot to it. The design of the form, I've basically got two labels, label 1 and label 2, one with the GPU name, the other with the real-time temperature. I've got a chart, so we're going to have to configure that. And I've got a timer, so every second or so I can update the value, the temperature reading, and then chart it in this scrolling chart. And you can see I select the timer, and it's got an interval of 1,000 milliseconds. And I've set it enabled equals true. You can have a button that enables that, but I just set it enabled as soon as I start it up, just like Libre Hardware Monitor or Hardware Info. When you start it up, it automatically starts grabbing the data. So that's basically it for the form. And what I've done is I have added the Nvidia API wrapper. So to get that, you just right-click on the project, manage NuGet packages, and go to Browse and search for Nvidia API Wrapper.net by Soroush Falahati. And when you install that, you've got these two using statements. We've also doing some lists so we can do the charting. We've done that many times in previous videos. System.link, we're going to be using Windows Forms and data visualization charting. So this is the application. Basically, I've got some properties. I do the initialize component. I configure the chart. We've got a method down here to do that. And the one thing I'm going to add from the Nvidia API wrapper is Nvidia.initialize. And that initializes the Nvidia API library. And now all of the control of this is going to go over to the timer event handler. So every second it's going to go through and grab data. So properties are, as I do in most of my charting applications, I've got two lists, one for the X vals and one for the Y vals. In this case, time values and temperature values. So the time values is a list of double, and the Y vals that it grabs is integers, surprisingly, for the temperatures. So I'm going to say list of int Y vals. And here I've got three numbers to set up the initial time for the chart. T-val min equals 0, we're going to use that in the logic down here. And then T-max, we're going to set it to have a chart that goes from 0 to 10 minutes. So T-max is 10. And here I've got two strings, one for the name of the GPU that we're going to grab, and one integer for the current temperature. And that's it for the properties. I've got two methods, one that actually goes out and gets the sensor info, that's the important part, and one to configure the chart. Here you can just take a look at this and copy and paste. We're going to line chart with a width of 3, x-axis minimum, maximum is Tmax, in our case 10 minutes, and the format's going to be F1. The Y interval is going to be 10, in our case degrees centigrade, and the format's going to be F1, and then we're going to clear the chart legends because we don't want them. But that's about it. So the really important stuff is going to be this get sensor info, and it's going to be driven by this one event handler, which is the timer tick. So basically every second it's going to get the sensor information and then calculate the time and the temperature that we can feed into the X vals and Y vals so we can chart it. So get sensor info. So at this point we've got the latest temperature, and what we're going to do is we're going to take the time value that we're incrementing every second, and we're going to convert it to a minute. And we're going to get T-val minutes equals T over 60. Convert the latest time step value to minutes. And then we're going to set it up so we can scroll the chart if we get past 10 minutes. So if T-val min is greater than T-max, so if the number of minutes we've been monitoring is greater than 10, we're going to remove the Y vals. That's how you scroll. We talked about this before. And we're going to add the T-val min to the X vals. And that's going to do the scrolling. And then all we do is we do a data bind XY, X vals and Y vals, and that will chart it. And here we fill out the label 1 and label 3. GPU name, I'm removing the first 7 characters because it says Nvidia. I don't care about that. And then the temperature to string, because it's an integer, with C appended to it. And then we increment the time. So that's basically just every timer tick, we're setting up the values and charting it. But the really important thing is right here, get sensor info. And you can see it's extremely easy to do. So the first thing we're going to do is we're going to get the GPU name, and then we're going to get the current temperature and add the current temperature to the Y valve so we can chart it. So with this wrapper, NV API wrapper, we can say the physical GPU is get physical GPUs, and that will give us an array of all the physical GPUs. I've got 2 on my machine, so it'll give an array. We're going to call it GPUs, and I'm going to use GPU 0, the first one, which is my 1080 Ti, and I'm going to get the full name property, and that's going to be the GPU name. So to get more information about this GPU object, we can go GPUs 0 dot, and you can get a list of all the information associated with that, right? Active outputs, BIOS, board, foundry, full name, handle, thermal information, so on. So basically it's going to give you a GPU with all the associated data. Then we want to get the temperature. To do that, we go GPU 0, thermal information, we just saw that, dot thermal sensors. So it'll take all the thermal sensors, and we're going to array to get an array of GPU thermal sensors called sensors. And then all we have to do for that sensors, take the 0th element, which is our 1080 Ti, and grab the current temperature. Again, you can do sensor 0 dot to get a list of all of the things associated with the sensor, but that's just giving you the current temperature. And then we're going to add that current temperature to our Y valves. In the timer tick, we've done the X valves, so now we've got everything we need to chart and display the name and the temperature. So now one thing to keep in mind, and one reason why we chose to start with getting GPU information, is that you can use the NV API code to automatically scan for all the physical GPUs. As you can see with this NV API wrapper, there is a method to get all physical GPUs. So that makes life a lot easier. You can automatically scan for the hardware. That probably isn't going to be the case with some of the other hardware. If we're going to start monitoring other hardware, it's probably not the case where it's really nice and easy. So keep that in mind. GPUs are nice, but don't expect that from the other components. Now also this NV API wrapper, really nice set of code. Some things to keep in mind. First of all, there is, in the GitHub, there is an NV API sample code. If you click on the program.cs, it gives you some sample code to go out and do a bunch of stuff. We don't need all of this. A lot of it is displays, monitors. A lot of the NV API code is directed towards your monitors, your displays. So there's a lot of code in here to show you how to do that. We just took one print GPU coolers where we went and got the temperature information, and also we scanned for the GPU. So most of this code in this sample you don't need. Now also, if you go into the NV API wrapper, you can see that there is a lot of code here for a lot of things. And you know, if you're like me where you want to make things more efficient, you can probably get rid of a lot of this stuff that we don't need. For example, there is a category of display. There's a whole lot of stuff for your monitor, your display. Mosaic, that is a Nvidia methodology for getting a grid of displays. Probably not going to need that. Stereo, probably some stereo hardware stuff you're not going to care about. So if you want to get really efficient, you can probably get rid of the reference to this NuGet package and just extract the code that you need for your application. It's up to you, just to make it a little bit more efficient. But real nice set of code here to make your life a lot easier and provide a C# wrapper around the NV API, which is mostly C, C++, I believe. Now in the next video, if there is a next video, if I get any views, we'll probably look into the next component that we can grab data from, and likely that'll either be maybe the CPU, or we talked about before a chip called the Super I/O, which serves to act as a interface to things like the motherboard fans, gathering data on that. So one of those two devices we'll look into and see if we can communicate with it and grab data, as you can see here. Other than that, if you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.